In this video, we are going to look at defining a new data type. To do so, we will be exploring a new concept, Python classes. Up to now, we've only been able to use data structure already provided by Python, like a list or a dictionary. It will be even more interesting if we could create our data types that can be used for our own defined problem. The procedural paradigm organizes programs around function or block of statement which manipulate data. On the other hand, the object-oriented paradigm, OOP, combines data and functionality and wraps them inside what is called an object. So far, we've been looking at the procedural paradigm. We've been able to create blocks of statement using if statement, for loops, and so on. And we've also been able to define function. The next step for us is to look at the object-oriented paradigm. We will be creating objects, and for that, we need to create classes. Classes and objects are the two main aspects of object-oriented programming. A class creates a new type where objects are instances of the class. An analogy is that we can have variables of type list, and such variables are instances or objects of the list class or the type list. An object stores data using ordinary variables that belongs to the object. Variables that belong to an object or a class are called fields or attributes. An object can also have functionalities by using functions that belong to the class. Such functions are called methods. This terminology is important because it helps us to differentiate between a function which is by itself and a method which belongs to an object. We often refer to fields or attributes as the state of the object, whereas the methods are referred to the behavior of the object. In other words, what an object can do. There are two types of attributes. They either belong to each instances or object of a class, or they belong to the class itself. They are called instance variable and class variable respectively. A class is created by using the keyword class. The attributes and methods of the class are listed in the indented block of code. To create a new data type, we'll be using the class keyword. The general form is class followed by the name of the new type. The statement terminates with a colon. Let's explore further by defining a new class rectangle. The new type of object rectangle contains some information to represent a rectangle. To create a new type, we must define a new class using the keyword class followed by the name of the class, which is rectangle. That's all we need for the moment. To have a working solution, we need to use the keyword pass in the indented subblock of code. To create a new instance of this object, we just need to call the name of the class followed by round brackets and assign it to a variable. In our case, we can write the statement r equal rectangle open close round bracket. We have now created an instance of type rectangle. To properly define a rectangle, we should be able to add its coordinate, x and y, and its property, that is, its width and its length. We can define new attribute for this instance by calling the object itself, followed by a dot and the name of the attribute. Let's define the attribute rx for the x coordinate of the top left corner and ry for the y coordinate of the top left corner and initialize both of them to 0. Similarly, we can define the width and the length attribute and initialize them to 1 and 2 respectively. We've defined our 4 attributes for this instance of the class rectangle: x, y, w for the width, and L for the length. How can we access these different values? For example, we could print the state of the object. Using the function print and the string formatting, I can display the attribute x and y of the instance R by using r.x and r.y. Let's run that code. The output shows the expected state of the instance R. That is the position 0, 0. So far, so good. Let's create another instance of the class rectangle. For example, P. Next, we should assign a state for the new rectangle. That is, its position and size. For example, we can set its position to the point 1, 2, its width to 3, and its height or length to 3 as well. P is in fact a square. Next step is to print the state of the object. Let's run the program again so we can see the position of both rectangles are printed correctly. What other properties a rectangle may have? We could, for example, compute its area, which is its length times its width. We can define a function, area rectangle, that takes a single parameter rect of type rectangle. In the body of the function, we compute the area of the rectangle rect by multiplying its width with its length. That is, we return rect.w times rect.l. Now that we have completed the definition of the function, we should update our output for the rectangle R by printing its area after its position, like so. Let's run the program again to check the output. As you can see, the correct rectangle area for R is shown after its position. Everything seems to be working fine. Similarly, we should be able to compute the area of P. It is a rectangle after all. Now that the output has been updated for both rectangles, let's check the output. That's not what we expected. The program crashes. The rectangle object does not have an attribute L. If you look closely at line 19, we made a mistake. We used the wrong name for the attribute for length. We use H instead of L. Nothing forbids a developer using your class to do so. So it is not entirely their fault. At this stage of the class design, we did not provide the necessary functionalities to instantiate a rectangle properly. And you can see the dangers that may arise from it. It would be useful to have a way to initialize an instance, which, given the full output for x, y, width, and length, creates the 4 attributes with their correct name and assigns them their corresponding values. Python provides a method to do so. The method __init __. And this is the subject of our next video.